All right, so this is the second part of 8.1. We're going to talk about inclination. Inclination is a new concept for you guys, but it's actually really easy. It says the inclination of a line is the angle, and this is called alpha, okay? So if you see something like that, I'm not very good. Wow, that was terrible. Whatever. So you guys get the idea. On a 0 to 180, so that means it can only be between 0 and 180 degrees. That is measured from the positive x-axis to the line. So, for example, this right here, I'm going to just give you what the measure is, but the measure is going from here right to the line, okay? So it's as soon as you get to the line in that quadrant right there, and that is, it's basically the measure of this angle right here, which is 155 degrees, okay? This one over here, same idea. If we're measuring it straight to the line, it's just going to be the measure of this angle right here. And we're going to call that 35 degrees. And again, this is important because we're going to use this. So inclination is just going to be the measure from the x-axis to the line. Okay, make sure that you are going counterclockwise. We're not going down like this. We're always going up here. That's why the domain here from 0 to 180 degrees is really, really important. We're just going up to the line. Okay, so hopefully that's pretty easy for those. So let's talk about how we can use this a little bit. And we're going to start with this slide on the left. Okay, we'll talk about this slide in a minute and how this applies. But if you're looking at this, this circle is a little bit small here, but here's what we're going to play along with. Okay, let's imagine that the angle between the x-axis, the inclination, okay, the inclination of this line that's coming off is 30 degrees. Okay, so that means that this line right here is 30 degrees and it's intersecting this circle. So what we want to do is we want to find the slope of this line. So here's what we're going to do. I know, and you know, you can see it, that the first point right through the center there is 0, 0. This point over here, we don't know it, but we can figure it out because we know that the angle is 30 degrees. Because you guys know by now that a 30-degree angle is going to create sides on a triangle where that would be 1 and this would be square root of 3. So if you think about it, our x value here would be square root of 3. So that's what this coordinate is going to be. The x value would be square root of 3 because you went over to the right square root of 3 and you go up 1. Okay? So that's the coordinate. So to figure out the slope of this line, we just simply use our slope formula. M equals y2 minus y1 over x2 minus x1. So essentially we have 1 minus 0 over square root of 3 minus 0. And that equals 1 over the square root of 3. And you all know that we have to rationalize the denominator. So we multiply both top and bottom by square root of 3. And that gives us the square root of 3 over 3. So that's what the slope of this line is. Now, if you think about what we just did there, look at this triangle. Opposite over adjacent. Opposite over adjacent is always tangent. So basically, that's where this slide comes in. For any line with slope m and inclination of alpha, where alpha is not 90 degrees, the following formula holds true. The slope of that line will always be whatever the tangent of that degrees is. So in this case, we knew the inclination was 30 degrees. If we figured out what the tangent of 30 degrees is, that would be equal to 1 over the square root of 3, which ends up being the square root of 3 over 3. So you get the same answer. This always holds unless it's 90 degrees. But again, think about it. If our alpha is 90 degrees, that means we have a vertical line, and a vertical line has no slope. So that's the reason why 90 doesn't work, and that's the reason why tangent of 90 is undefined. Okay? So we will be using this to find slopes of lines coming up out of the origin like that. We can use tangent of whatever our inclination angle is. Okay, so that does it for this video and for this section. Don't forget to take your Edmodo quiz if it's been assigned, and I will see you guys in class.